Hello everyone, welcome back to my channel Saisha. This is Amuk Kaliwa. If you are new to my channel, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. In the last video, we understood about boosting algorithm, that is AdaBoost. We started with the decision stump, thereafter the diagrammatical representation of understanding of our AdaBoost algorithm, and thereafter with an example we deciphered the AdaBoost algorithm. We concluded the last video with the comparison between the random forest and our AdaBoost. In today's video, we will continue with Ensemble boosting algorithm, wherein we will understand about gradient boost algorithm. We will initially compare the gradient boost algorithm with the AdaBoost which we have learned in the last video. Thereafter, we will utilize the example for understanding the in-depth of gradient boost algorithm. We will finally conclude the video with the mathematical representation of gradient boost algorithm. The comparison between the AdaBoost algorithm with gradient boost algorithm can be done using three main key components: the trees which we are building, the focus of the algorithm, and the weights provided to each of the tree or the learner. Here in gradient descent, we are using weak learners, that are decision trees, which are built greedily with some impurity. This impurity might be an entropy or Gini index. Whereas in AdaBoost, we use weak learners as decision stumps. The primary focus of the gradient boost algorithm is to minimize the loss function. Whereas in AdaBoost, we train upon the misclassified observations which were in the previous tree. Similarly, the weights which are provided to each of the learner or the tree are same in gradient boost, that is equal weights. Whereas in AdaBoost, the learner weight depends on the prediction accuracy of that learner or the tree. To understand the gradient boost algorithm, we are going to consider an example. The example has three independent attributes, that is height, favorite color and gender, with a target attribute as weight. To start or kickstart the gradient boost algorithm, we consider the first predictions as the average of our target attribute. In this scenario, 71.2 is the average of our target attribute weight. With that, we will calculate the residuals. Now, what are residuals? Residuals are the difference between the actual target attribute minus our predicted attribute. In this scenario, I am subtracting all the values with 71.2 and we have the first residuals. With this first residuals, we build a decision tree. To build a decision tree, we will consider the three independent attributes and first residual as our target attribute. The decision tree looks like gender is equal to female as our root node, with height less than 1.6 and color not equal to blue as our child nodes, with some of the values in the leaf node. Now, when we are utilizing gradient descent, we use a parameter, that is a step. This step is also called as learning rate. In this scenario also, we are going to consider a learning rate. That learning rate is 0.1. With this decision tree, we predict for each of the observation, and that output is multiplied by my learning rate plus my previous predicted value for the tree, that is 71.2. That will be my new predictions. With that new predictions, I subtract it with the actual weight value and get my second residual. Now, for the third tree, I will take the independent attributes and the second residual and build the third tree. After that, the process continues. This process is halted when the number of trees which is specified to the algorithm is complete or the required metric is achieved. This is how you build a gradient boost algorithm. Now, let us understand the crux of the gradient boost algorithm mathematically. Let us understand the mathematical representation of gradient boosting algorithm. The gradient boosting algorithm consists of two parts: the input, the output, and the algorithm steps. For the input, here we have considered a data which has two parts, that is the independent features x of I and our target attribute y of I. Here I represents the number of observations in the training data set. With the data, there is also another component, that is a loss function, which is differentiative. So here it is represented as y of I comma f of x, where y of I represents the target attribute, f of x represents the predicted values. The loss function can be utilized any of the loss functions which is suitable for our data set. In the step 1 of our algorithm, we initialize a value, that is the model has a predicted value which is a loss function of our target attribute minus the average of the values. Thereafter, we go on a iterative mode. This iterative mode consists of the models from 1 to m. In this, what we do is we compute the residual values. This residual value we will utilize our previous initialized model value and calculate. Now, what does the residual value represent? It is just a differential of the loss function with respect to the predicted values. Now, after getting the residual values, what we do is we fit a decision regression tree with our residual values as the target attribute and the input features x of I. After building the regression trees, we calculate the predictions for each of the x of I component. In this step, we can observe that computation which is happening. Here, we consider even one of the step criteria for the modification or calculation of our predicted values. Thereafter, we update our predicted values. This predicted values is a combination of our previous tree predicted value plus our step that is the learning rate and our new predicted values. This is how we can visualize our mathematical model of gradient boosting algorithm. If you like my video, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. Thank you.